We're counting down 6 of the weirdest facts behind the Dodge Charger Daytona, where racing legends, engineering rumors, and hidden controversies collide. From misunderstood materials and surprising dealership drama to record-breaking feats and secrets that bent the NASCAR rulebook, each fact moves from technical myths to revelations. Which little-known detail tops the list? Let's kick things off with number 6. Most people assume the Charger Daytona's pointed nose was made of lightweight fiberglass. The truth is far more industrial. Every production Daytona left the factory with a nose cone crafted from stamped sheet metal, just like the rest of the car body panels. This decision added roughly 100 to 150 pounds to the front end, but it made the nose far stronger and more crash-resistant than any fiberglass alternative. Restorers can spot the difference by the distinct stamped seams that only sheet metal construction leaves behind. One expert points to the stamped seam only sheet metal creates. Underneath, massive Z-brackets anchor the nose to the frame, a design built for the rigors of NASCAR, not just showroom flash. The extra weight was a trade-off for durability, busting the common myth that these cars wore a fragile, lightweight front end. Dealers faced a problem when the Daytona's extreme nose and towering wing turned off everyday buyers. Some salesmen took matters into their own hands, stripping off the signature aerodynamic parts and welding shut nose mount holes to disguise the cars as regular Chargers. Service invoices from the era list labor for removing wings and patching fender scoops, all to get these oddballs off the lot. Today, restorers sometimes discover hidden welds or bondo where a nose cone once sat, proof of a hasty dealer conversion. These altered cars now fetch only a fraction of the 7-figure sums paid for untouched originals. It seems almost criminal in hindsight. Dodge built exactly 503 Charger Daytonas in 1969, just enough to satisfy NASCAR's strict homologation rule, which required at least 500 street-legal examples to qualify for racing. Factory records show a frantic push to hit that number, with final cars rolling out in September. Of those, only 70 left the line with the legendary 426 Hemi engine, while the rest carried the 440 Magnum. Despite their race-bred pedigree, many Daytonas sat unsold for months, their radical looks too much for most buyers. Today, fewer than 200 are believed to survive in original form. Auction specialists say documented provenance, like matching VINs and build sheets, can mean the difference between a 6-figure clone and a $1 million icon. A lot of people think the Daytona's giant rear wing was set so high just to clear the trunk lid, but that's a myth. The real reason goes back to Dodge engineer John Pointer, who insisted the wing needed to sit up at roofline height, about 23 inches above the deck. Wind tunnel tests showed that air closer to the roof is much less turbulent than the chaotic flow behind the rear window. By raising the wing into this cleaner air, the Daytona gained far more downforce and stability at speeds above 180 miles per hour. The fact that the trunk could still open underneath was just a happy accident. Pointer said they wanted the wing up where the air was smooth. The result was a car that sliced through the air with purpose-built precision, setting the stage for the Daytona's next big record. On March 24, 1970, the Dodge Charger Daytona broke through a barrier that had defined racing for decades. Buddy Baker, behind the wheel of the number 88 Chrysler engineering car, pushed the Daytona to 200.447 miles per hour at Talladega Superspeedway. NASCAR officials stood trackside with stopwatches and timing sheets, confirming what had seemed impossible just a year earlier. Baker said it felt like we were flying. For the first time, a stock car had circled a closed course at over 200 miles per hour, 30 miles an hour faster than the Indianapolis 500 pole speed that year. The DC-93 Daytona was not just fast, it was a rolling laboratory of aerodynamic innovation, proving that every inch of its radical design paid off on the track. Historians still point to that day as a turning point, when engineering and bravery combined to set a new standard for speed in NASCAR. The Charger Daytona's rear-facing fender scoops looked like simple styling flourishes, but they covered one of the car's most controversial secrets. Behind each scoop, Dodge engineers cut holes straight through the inner fender liners, creating vents that let high-pressure air escape from the front wheel wells. On paper, these openings were justified as providing extra clearance for the massive racing tires. In reality, they served a hidden aerodynamic purpose, reducing lift and drag at the front end. Wind tunnel smoke tests and modern restoration cutaways reveal how air, trapped and swirling around the wheels at 200 miles per hour, found a clean exit path through these vents. The result was a measurable drop in front-end lift, estimated at up to 15%, and a car that stayed glued to the track at record speeds. NASCAR's 1969 rulebook required production features to be functional and identical on street and race cars, but nothing specifically banned this kind of pressure relief. Dodge's official line was always tire clearance, and that technicality kept the Daytona legal. Still, many historians argue these scoops were a clever loophole, blurring the line between smart engineering and outright rule-bending. As one motorsport historian puts it, if NASCAR had realized what those vents really did, the story of the Daytona might have ended very differently. Across all 6 facts, one truth emerges. Pushing limits means bending rules and defying expectations. The Daytona isn't just a car, it's proof that real innovation never plays it safe.